All right, I'm here at IMTS with John Tuohy from FANUC. John, it's IMTS 2024. You and I have known each other now for 3 IMTSs, but I want to know what your story is, man. Tell us how you got into this role that you're in with FANUC now.
Well, it's a long, convoluted story, but it's a very exciting one. So I started out my career with Shunk. I spent about 18 years at Shunk developing the automotive market for the Shunk team. And then in 2016, it was actually an IMTS. Lou Finazzo, who is our vice president of sales and marketing today, was not that role 10 years ago, but came up to me and said, John, it's finally time you work with me. And that was that. It was no problem. I couldn't wait. I started with FANUC 10 years ago, right after the show in 2014.
That's awesome.
So super excited to be part of the FANUC team. As you can see, we have a very, very large booth behind me. We actually have our new M800. It's a laser cutting robot dual-link photor, IP65 rated. In fact, this is Ian. In fact, if you want to get Ian, he's the engineer who's the expert on this, and maybe give a 2-second overview.
Oh, yeah. Ian, tell us a little bit about this.
Our new R50 controller, brand new M800V, which is a factory signature calibrated robot.
Okay.
And there's primary and secondary encoders. So we're measuring where we told it to go and where it actually is.
That's awesome.
It's a super accurate robot.
I love it.
And then we have our new LIU2 talking to the Trump laser.
Yeah.
And with that, we can pulse the laser on and off at 1 millisecond intervals.
Wow. That's really cool.
So besides the M800 being a new product, we have, as we get upstairs, you'll be able to do a panoramic of the entire booth. But along this line, we also have some other interesting products. First of all, I'd like to show our 5-axis impeller cutting. So we utilize both a full simultaneous or a 3+2 or 4+1 option. So FANUC is truly the innovator in 5-axis.
It's really a cool machine, John.
It is. So everything, you look at the RoboDrill machine, and it's going to have the flagship FANUC control, the 31IV5. It comes loaded with everything that FANUC has to offer from a software perspective. The machine, very soft, very light, very flexible, and extremely fast. It's the fastest cut to cut and the fastest tool to tool. So when you're looking at 1.7 seconds cut to cut, nobody can beat that. As we move down here, we have...
That's an astronomical statistic, John. All right, so what do we have on this one?
So what we're looking at is a 4-axis, simultaneous 4-axis machine cutting. And what we're doing is we have a hunk of steel down here. And what we're going to do is show different mill, drill, tap. And also we will hog a 10 millimeter chunk out of this piece when the demo gets running.
Wow.
Okay.
Another interesting concept in the RoboDrill product line is today we have the opportunity to add a component that will turn this into a mill turn. So in this application, what you're seeing right now is a turning application on the RoboDrill because of what we put on the 4th axis. So now I can mill, drill, trap, and turn on a RoboDrill.
What can a RoboDrill do?
Parts over a meter. That's about it.
Yeah, I like that.
Speak of that, this is our new Y500 machine.
Yeah.
So if you look, this is a very large part. What we've done on the Y500 is now we've got a 100 millimeter deeper column. So it affords us the opportunity to put larger parts in and have access to the other side by using a larger trunnion. So the Y500 will give us an opportunity to chase more applications in the automotive space.
I love it.
My name's John Moldenhauer. I'm with Methods Machine Tool.
All right.
And like say over the C800 IC machine. This is FANUC's largest machine, X and Y travel. This is 12 inches in Z. We have one larger that goes up to 20 inches in Z height.
Wow.
The machine will thread automatically submerged underwater, no pipe guiding it down from full 20 inches in Z in open water all the way down to the lower nozzle and connects and then cuts.
That's really neat, John.
It's easiest when there's a start hole.
Yeah.
But if there's no start hole, it'll do it. The worst case scenario, if it's in open water.
Wow.
FANUC has best, by far, the best automatic water feeding system on the market.
That's amazing. Phenomenal.
This machine goes from 4 thousandths diameter wire up to 12 thousandths diameter, depending on usually the thicker parts, larger diameter
Yeah.
wire, but it really depends on the detail, how small the inside corners have to be.
Okay.
And this machine in 5 passes can get a surface finish below a 10 RA with a standard power supply on the machine.
That's really cool.
Yeah.
Jason, what?
So I'd like to introduce Jason Munson. Jason is part of our ACP welding team. And Jason is responsible for one of our largest relationships in the welding world. And he's also responsible for this cell.
Jason, tell us about this cell.
So what we have here is a hard-facing and welding application on a large auger. We're using a servo robot laser seam tracking sensor to track the outside seam. So for this particular part, you'd want to put an additional layer of weld on there for abrasive resistance. You can also use through-arc seam tracking, which monitors the current of the weld to weld the inside of the flutes for the auger. So we're going through non-welding, but demonstrates the application really well.
Yeah, very cool. Thank you very much, man.
Thank you.
All right, where to next?
We're going to go down this way. So what we've got here, this is a demo where we're actually showing the connection from the robot to the CNC. So traditionally, when people have done integrations, you've looked at 16 to 18 hours of either hard wiring or discrete I/O. Those are really the only two ways you could have ever connected a robot to a machine tool. Now, what we've done is we've taken this wire right here. This is the only communication between the robot and the machine tool. And what I'm doing is we use a piece of software called Robot Onsite. And in this particular case, this robot is able to be programmed in G-code. Wow. So I can use the MPG, I can use the HMI and the machine tool. And the idea is that the time to integrate this robot will go from 16 to 18 hours to I can have this picking 2 hours out of the box as long as I have my gripper fingers figured out and my work holding figured out, which most people will have done at that time. So every integration now, when you go FANUC to FANUC, I can get you picking quickly.
So what's that do for the skill set of the people that companies are then looking for, right? Because if they're able to program the robot with G-code, the same thing that they're using to program the machine, does that lessen the ramp up to get people proficient in robotics and machining?
That's a great point. I know the fact that what we've been doing is trying to make the robot more accessible to to the masses.
Yeah.
And when you're out on a shop floor, a lot of the intimidation is of a guy trying to learn a new programming platform. Now, one thing about programming platforms, whether it's on our CNC or on our robot, our language has been consistent for 40 years. But today's robots, the CRX, they are extremely easy to use because I've got a tablet interface that I can use drag icons, or I can actually drag the robot around and do lead to teach, or I can do it in a traditional way with a teach pendant. In fact, this is the engineer who's responsible for this. This is Greg Buell.
Hey, Greg. Jim Mayer, nice to meet you.
Pleasure. So Greg is he built this system, and he is probably our expert right now on the communication protocol between the FANUC robot and a CNC. He's got a very unique skill set.
Yeah. That's not one that you see a whole lot of resumes hold, right?
So Greg has actually designed this cell to showcase the flexibility and how quickly and easy it'll be to automate a FANUC-controlled machine.
So how
Not
long?
to say we can't do other machines, but FANUC to FANUC is where this software works.
Well, and FANUC to FANUC, I mean, it fits in a relatively small footprint, right? And that's what I've always loved about FANUC machines in general is their footprint, the space that they take up with the capabilities that they have.
Yeah.
It's pretty amazing.
Yeah.
The key to our interface really is, your FANUC controller on the robot, FANUC controller on the machine. You don't need to do an I/O configuration between the two. You just talk to each other.
Yeah.
So you don't have to figure out if you're using DeviceNet, Profinet, Ethernet IP, no PLC needed.
Yep.
Plug in the cable, set your IP addresses,
Because really what happens
Right
is
program.
the robot becomes a second channel of the CNC. And all I'm doing is exchanging macros.
Yeah.
So the robot will call, and actually in this configuration, the robot is the master, the machine tool is the slave.
Okay.
So the machine tool will call for service, load me, clean me, unload me, whatever. So it's just a second channel. It is extremely efficient, extremely fast. And then when you start coupling FANUC reliability from the CNC and the robot, now you've got a cell that's going to give you hours and hours and hours of unmanned. You know, as long as you got parts in front of it, it'll work.
Your productivity time is absolutely unparalleled at that point.
Correct.
I love it. All right.
Cool.
What's next, dude?
Thank you.